Hello, Luke. Welcome to Lesson 41. So today we'll be talking about addition of like terms in rational expressions. Remember, rational just means fraction, so in fraction expressions. And then we have two-step problems. So before we get started, let's just remind you of a couple of things. Two things, really, that we'll be focusing in on today's lesson. The first thing is we have to remember that in order to add fractions, they have to have a common denominator. And then we can add the numerators. All right, that's old news. It's something that you've learned a long time ago, but it's good to kind of just keep that front and center right now, because once we throw variables in, it can make things look, anyway, a little bit more confusing. The second thing is just to remember how to add like terms. Remember, when adding like terms, they have to have the same variables. All right, so these two things, we really need to have those front and center in our minds in order to make sense out of what we're doing here. So let's start by just looking at some fractions, and let's keep it simple. So if I have two fractions, let's say I have 3/16 plus 5/16. All right, and I'm combining those. Can I add these? Well, sure, I can, right? Because they each have the same denominator. They have a common denominator. And whenever we have that, we can add the numerators and place them over the common denominator. So this is going to be the same thing as 3 plus 5 over 16, right? I'm placing both numerators over the 16, the common denominator, and I'm adding the numerators, which then in turn would give me 8/16, right? This is a very simple problem that we've done many times before. So, but the point here I'm trying to remind you of is that in order to combine fractions, we have to make sure that the denominator is the same. If it's not the same, we cannot add them yet. So if I have 1/2 plus 3/4, I can't add these yet. The first thing is to get these two denominators the same. And remember, there's a whole process to do that, but we won't go into that right now. All right. So let's complicate things a little bit here by switching out some of these numbers for variables and see what happens. So let's say that I've got 3 over x plus 5 over x. What can I do here? Can I add them? Well, sure, I can. The denominators are the same. I have an x and I have an x. They're the same one. So I can place my two numerators over that x and combine the numerators, just like I did in this first problem. So I have the 3 plus 5 equals 8 over x. All right, it's that easy. Again, the point to remember here is we can only do this because the denominators are the same. Okay, let's try another one. What if we've got 3a over an x plus 5a over an x? Can I add these? Well, sure. The denominators are the same, so it's all going to be over the same denominator. And now I can add the numerators, 3a plus 5a. Okay. In this case, 3a and 5a are like terms, so we can add these. And that gets to the second point over here. We can only add terms when they are like terms, and these are, in fact, like terms. The variables are the same. So 3a plus 5a is going to be 8a over x. Okay? Let's try another one. What about if I've got 3y over x plus 5z over x? Can I combine these? Well, again, we've got the same denominator, so it's all going to be over that denominator. It's going to be over the x. And then in the numerator, we're going to have to add these other numerators. We get 3y plus 5z. And in this case, I can't combine anything in the numerators here. They're not like terms. 3y and 5z are not like terms. So there's nothing else I can do, but this would be my answer right here. It's a little bit messy, but that would be my answer. I combined the numerators over the common denominator. All right? Pretty straightforward. So let's talk about more complicated problems. Um, let's go to this one. So looking at this problem, if you're being asked to simplify it, well, the first step in simplifying is usually trying to find like terms, right? If we see like terms, we want to combine them to simplify the problem. But in some problems such as this, it's actually pretty difficult to see if there are any like terms, right? It's just kind of messy. Is it easy? Is this first term? Is this a like term with the second term? Well, let's see. We have b's and x's and y's, and we have b's and x's and y's, but they're all kind of messed up and moved around, and it may not be obvious whether or not these are in fact like terms. So the first step is to really try to rewrite this problem as, to rewrite all the terms, I should say, in a particular form. All right. And it'll make it easier to see if they are like terms. So let's pick our form, and we can pick any form we want. We could say we want to write all of these terms with the exponents positive. Or we could say, let's write all of these terms with the exponents negative. Either way is fine, as long as we do it to all the terms. I'm going to choose to try to write these terms with all the exponents positive. So if we do that, we have a b and an x. They're both positive, no problem there. X to the third, that's a positive exponent, so that's fine. Y to the negative 2, that's a negative exponent. So let's move him up to the top of the fraction so that exponent becomes a positive 2. Remember, the sign switches. All right, now we can go on to the next problem. We have a 3, and then we have a b, and then we have a y squared, and then we have an x to the negative 2. Well, we're going to get rid of that negative exponent by moving this x to the negative 2 into the denominator. Because remember, it's hidden, but this is in the numerator. So let's move it into the denominator, and that x to the negative 2 will become x squared. All right, and then we move on. We have a 4, and we have a y squared, and that's all over b to the negative 1, but let's move him up to get rid of the negative sign, so he just becomes a b, and then in the denominator we're left with just an x squared. And now, lo and behold, looking at this, well, actually there's one more thing we can do here, isn't there? Let's look at this first term. Now that we've kind of had everything, written into a form that we like with positive exponents, is there anything else we can do to simplify? And sure enough, there is in this first term. I've got an x in the numerator, and I've got 3 x's in the denominator. These can cross out. This x can remove one of these 3 x's, and this becomes an x to the x squared, right? So now I have by squared in the numerator all over x squared in the denominator. Minus, is there anything I can do here? No, there isn't. So I still have 3by squared all over x squared. And over here, there's nothing I can do either. So I have 4y squared, b over x squared. And now, look at our denominators. They're all the same. The denominators are exactly the same for each term. So we can actually combine all of these. Okay? And we combine them just like we did in the previous problems by writing all of these terms over the single denominator x squared. All right? And we have for our first numerator by squared. And then we have a minus 3by squared. And then we have a plus, and I'm going to write this one in alphabetical order, a 4by squared. Okay? And now, lo and behold, we can actually see that all 3 of these terms are like terms in the numerator. The variables are all the same. So we can combine their coefficients. So the first one has a coefficient of 1. So a 1 minus a 3 is a negative 2. And then a negative 2 plus a 4 is going to be a 2. So we end up with 2by squared all over x squared. And that is as simplified as we can get it. But look how cool that is. So we've taken these three rather noisy and messy terms, and we found that we were able to combine them and make them into one much nicer term here, just by simplifying. And we did that by first getting it in a form that we liked. So in our form, we decided to put everything as a positive exponent. And once we got everything up into a positive exponent, we looked through to see if there's any, reducing that we could do in each of the fractions. But then once that was done, it was very easy to see that, oh my goodness, these are like terms. We can add them. All right? So let's try another one. So why don't you pause the video? Try this one on your own. I just want you to simplify it, and then we'll do it together. All right, so here we have a bunch of negative exponents. Just for the fun of it, I'm going to do this one by putting each term in the form of having negative exponents. We'll go the opposite here. So we're going to make everything a negative exponent. So we have a to the negative 3. Well, that's already a negative exponent, so that's fine. The b is a positive 1, so we're going to move that into the denominator to get it to a negative 1. And then this b to the negative 3, well, that's already a negative, so that's fine. And then over here, we've got a 2, and then a b to the 4th. We're going to move that down, so it becomes b to the negative 4. And then a to the 3, we're going to move that one up, so that it becomes a to the negative 3. All right. Now let's look to combine anything that we can in each of these terms. The first one, we can say that, okay, nothing can be done in the numerator. In the denominator, sure, these are being multiplied by each other. So when we multiply same variables, we add the exponents. So b to the negative 1 times b to the negative 3. Combine the exponents. Negative 1 and negative 3 is a negative 4. So we end up with b to the negative 4th. Plus, over here, there's nothing we can do in the numerator. And in the denominator, well, there is nothing we can do either. There either. And now we do have common denominators, b to the negative 4. That's great. We can add them. So let's put the whole thing over the common denominator of b to the negative 4. And we're going to add our numerators. So we have a to the negative 3 plus 2a to the negative 3. And lo and behold, isn't this wonderful? We do have like terms in the numerator. So we have a 1, a to the negative 3 plus a 2, a to the negative 3. That's going to give me a 3a to the negative 3 all over b to the negative 4. All right. Now, if you had decided when you did the problem to write these as we did in the last problem with positive exponents, you'd have the same answer, or I should say you're going to have an equivalent answer. Your answer, though, is going to be then taking these negative exponents and making them positive. So we would have our 3, but then the a to the negative 3, we'd move that down to make it a positive. And this b to the negative 4, we'd move up to turn that into a positive. So if you had decided to put everything into the positive exponent form, this is the answer that you would have gotten. If you decided to go negative, you would have gotten this answer. Either one is correct. They are equivalent. They're just another form of the same answer. All right? Very good. Let's try one more. So pause the video, try this one on your own, and then we'll do it together. Okay, so let's make them positive. I actually like having positive exponents as opposed to negative exponents. So let's make them all positive this time. So we have 3a to the 4th, but then we're going to move this c to the negative 2 up. So he's going to become c squared. All over an x, we're going to keep him in the basement there, in the denominator. And then over here, we have our 4. The x to the negative 1, we're going to move down, so it becomes an x. Then we keep our c squared. And then in the denominator, we have a to the negative 4th. We're going to move that up, so it becomes a to the 4th. And then over here, we have 2c squared all over x, and then we'll move the a up, making it a to the 4th. Okay. So once again, obviously this is a contrived problem because we have common denominators again. Isn't that just amazing how that happens? So we're going to combine these. We're going to place all of them over the common denominator, x. We'll add the numerators. So we have 3a to the 4th c squared plus 4c squared a to the 4th plus 2c squared a to the 4th. Okay, and then looking at that, I mean, this one isn't written in alphabetical order. Maybe I should have done that. But they all have an a to the 4th, and they all have a c squared. So they are like terms in the numerator. So we can combine those, and we can add the coefficients. So 3 plus 4 is 7. 7 plus 2 is 9. So we end up with 9a to the 4th c squared all over x. All right? Very good. All right, so moving on now to the next part of our lesson for today. Very easy. We're talking about two-step problems. And basically all this means is we're given an equation to solve for a variable, and then we're asked to use that variable, the value of that variable, to solve for an expression. Okay, so if x plus 9 equals 12, what is 2x plus 4? So the first step in this problem is to solve this equation. X plus 9 equals 12. Let's find out what x is. And we do that by solving the equation. So we'll subtract 9 from both sides. We end up with x is equal to 3. Now, if x is equal to 3, what is 2x plus 4? Well, that's all that means is we are doing an evaluation problem. We're taking 2x plus 4, and we're evaluating it if x is equal to 3. Okay? So let's plug in a 3 for the x. So we throw in the 3. I'll just put an equals here. And that is going to equal 2 times 3 is 6 plus 4, which is equal to 10. So that would be our solution. So it's very straightforward. It's just a two-step problem. We're solving an equation to find the value of an x, and then we're evaluating this expression with the x being equal to whatever the solution was over here. All right, so let's try another one. Go ahead and try this one on your own, and then we'll do it together. All right, so if x minus 4 is equal to 16, what is 2x plus x squared minus 2? All right, well, let's first solve for x. Let's find out what x is. So we're going to add 4 to both sides, and we end up with x is equal to 20. Okay, and now we have to plug that in to this expression over here. So we have 2 times 20 plus 20 squared minus 2. So 2 times 20, well, that's equal to 40 plus, what's 20 squared? Well, 20 squared is going to be 400. Now, if you wanted to do it out here, remember 20 squared means 20 times 20, and you'd have to just do the work, but, whoops, 20 times 20 is in fact 400. So we have plus 400 minus 2. Now it's just a matter of adding this up. 40 plus 400 is 440. 440 minus 2 would be 438. All right, and that would be our solution. Excellent. Well, I think we will stop there for today. Pretty straightforward lesson today. Go ahead and work on the assignment problems, and I will see you tomorrow.